All right. Our next topic is structural capability and credibility looking to the future, presented by Mr. Colin Clarke.
Thank you. So, good morning, everybody. Thank you for joining the presentation today. The title is Capability and Credibility, and I'd like to show you some of the things that we've been working on with our process additives and some of the possibilities for the future. But before looking at the future, just a couple of words about our history. We are quite a well-established company, and we'll celebrate a couple of milestones. Our production site in Hamburg is 100 years old today. We started, and the company overall is 150 years old. So we have really quite a long history of producing chemicals in Europe and also expanding into the world. Actually, we produce process additives, so our targets are really to give you the chances to optimize your processes. So we have specialty chemicals that can work very well within your compounds and your processing to improve the efficiency of your compounds. And we'll show you that later on. We are backed up by a very extensive distributor network in the Asian region. We work with Jebsen Jessen. Some of the colleagues are here. And please visit our booth 2 steps along, that we have really all of the information about our products. So worldwide today we have 6 production sites and quite a good footprint of manufacturing and distribution. 3 plants in Germany, 2 plants in the US, and 1 new plant in Asia, really dedicated to process additive production. So these are our sites, and in detail we produce a lot of additives for different end-use applications, but in fact rubber is really at the heart of what we do. So we produce rubber additives in 4 out of our 6 sites. So we're very heavily focused on additives for all kinds of rubber compounds. This is really one of our main businesses. We're a mid-sized company, about 500 million euro turnover, 1,000 employees, and about 1,500 tons, if you like, of product. We don't produce polymers, we don't produce fillers, we produce specialty chemicals. So this is quite a big number when you think about the very small volume of product used in compounds. Actually, we are very automated in our production. We don't have so many employees. Most of our processes are very automated. So we have very few production guys, much more focused on service and application and product development. So 1/3 service, 1/3 development, 1/3 production. Just an overview of how a plant would look like. This is our production site in Hamburg. I don't want to go through everything, but it's really open. If you're ever in Germany, please pay us a visit in Hamburg. We are very proud of our site. Come and visit us. We will show you our labs. Okay, so everybody talks a little bit about sustainability these days, and actually this has been a focus for us for a number of years. We'd like to show you how we use sustainable raw materials and how we try to improve the efficiency of our processes. Actually, this kind of responsibility is at the core of our business, alongside health and safety and quality. We see sustainability and environmental protection really as a very key requirement for our businesses today. We can track our improvements, so even before we really look, before COVID, we really already started to work on that, and we had sustainability targets going back already more than 10, 15 years ago. Today, we're really focused on developing bio-based materials and recyclable raw materials, together with improving our energy efficiency, so reducing our carbon footprint and going forwards to have a greater impact, if you like, in environment, looking at CSRD in Europe, EUDR, European regulation, and really certifying our products to be highly sustainable and energy efficient. So I'd like to talk to you a little bit about the 3 different groups that we have in terms of rubber additives: our dry rubber additives, our release agents, and our latex dispersion products. These are the 3 different business units within our polymer division. Of course, we fit our products very well into the circular economy, if you like. We are already using recycled raw materials, bio-based products as feedstocks. We work to have more and more energy efficient processes, so to reduce the energy consumption in our plant. We have very innovative logistics, so we reduce logistics costs, we reduce packaging costs where possible. We certainly contribute to efficiency of the end user, so our tyre makers, our rubber part makers can reduce energy consumption in their plants by using our additives. And of course, we try to recycle then products back into the process. So our products really fit into the circular economy. Our feedstocks, 4 main feedstocks if you like, fatty acids, metal oxides, resins and some specialty products. These are all primarily recyclable or bio-based renewable resource materials. So we really work hard to have these kind of more sustainable origin feedstocks into our productions. Alongside the standard products that we have, we're really working hard to bring more green, more sustainable offsets to those products to raise up the sustainability index. Some of the newer products reach 100%. This isn't really detracting at all from their efficiency, so to have very efficient, highly active products with a more sustainable feedstock, if you like, as new generation products. So there's quite a nice pipeline of new products on the way to increase, if you like, the sustainability aspect. Actually, internally, we are controlled by a sustainability index dashboard. This is a metric that we see on our internal network, if you like. It's a snapshot of our products. Our first target was to reach at least 50% sustainability. And more products we can push to be very, very, very high sustainable index, if you like. Some products 100% sustainable origin materials now. Of course, a few products, due to the chemistry, will not reach that. But more and more we aim to go over our benchmark, our borderline, to have more than 50% sustainable content. So let's have a look at some of these products and pick out some of the key advantages and a little bit, if you like, highlight, snapshot some of the way these products work. So we'll look at some tyre additives at first. We have applications, we have additives for all components within the tyre, whether we're talking about body components like the carcass, the inner liner, the reinforcement. We have process additives for that. Many process additives focus on the tread elements, where we see a lot of technological development. So let's look a little bit more in detail at the tread, if you like. Actually, we can track the development of tread compounds, particularly passenger compounds, to the increase in silica loading. So 20 years ago, silica was not a thing. Today, more and more silica is used in passenger tyres, starting in Europe and now spreading really globally. If we say initially, we had silica really very low level and we had very standard zinc soap products in use. Later on, silica increased and we needed to modify those products to be more active towards the silica. And today, actually, in passenger tyres, certainly in Europe, there's more silica than polymer. More than 100 parts of silica, maybe up to 150 parts of silica. The challenges change, and so the additives must also change to be much more active towards the silica. So we can really say 3 generations, if you like, of development in tread compounds and associated developments in the process additive technology. So early generation products, very standard materials, so zinc soaps, lubricating, reducing the viscosity, solving things like reducing the energy consumption. Batches that were very crumbly and difficult to handle could become more solid, but more or less very standard products. They gave improvements, but also some limitations, maybe softening effect or not fully satisfying all of the tyre properties, if you like. So later developments, now we could start to see really improvements in the handling of the compound. I don't know if we can click the videos, please. Thank you. And maybe this one also. So this is a modern tread compound. It becomes very sticky, very high loading of silica, high loading of resin, really difficult for the operators to handle. So it's really difficult to get good release for that type of compound. With the process additive in place, the same compound, the operator can take the material away very easily. So this is an example of the really targeted release and much improved handling of a modern tread compound. Of course, these compounds are very difficult to extrude. The high loading of silica gives us a very rough extrusion. By applying a low loading of suitable process additive, we can really smooth out the extrusion and make the tread really much more regular and uniform, if you like. But that's not the end of the story, because the tyre makers push the silica level even higher. And so, of course, new challenges mean new additives. And now we have additives that really target to improve the silica dispersion. We can see dispersion from 77% up to 90% with additives. So really targeting to strongly interact with the silica and maximize the filler dispersion. And finally then really, if you like, functionalized liquids, so reactive products that sit somewhere between the process oil that you use and the polymer, or the resin if you like. We can position then reactive liquids that can strongly interact with the polymer and the silica to maximize both the processing and the properties of the tire. Okay, let's jump maybe a little bit to the second pillar that we have. These are additives for latex. So we understand the demands of processability, and we want to apply that to liquid products, water-based products, to improve processing in latex articles. Actually, we offer again wide range of process additives through viscosity modifiers, tackifiers, defoaming stabilizers, peptizers, detackifiers if you like. So the same targets, the same process challenges that we see in dry rubber, we can also extend to the latex industry by producing water-based dispersions. So again, a wide range of products. This is the process flow chart, if you like, for rubber article producing, at least in the dipping process. Most of our additives are applied in the latex bath itself. So we have viscosity modifiers, tackifiers, dispersants, some coagulants, so some additives, release additives that we can apply in the coagulants, and some additives or the release additives that we can apply towards the end of the process. So it's not only about choosing the right additive, it's really targeting the additive to the right point in the process. And this is something that we understand very well from an application point of view. It can really help you guys in that process. Just an example with some of our viscosity modifiers. So to change the viscosity, to change the spread of a latex compound, we can increase the viscosity, very shear dependent. So if you have a high shear process or a low shear process, we can thicken or reduce the viscosity of your latex compound with a very low loading of an additive to improve, if you like, the coating of textiles. So really ready to use, very easy to disperse viscosity adjustment technologies. So things like textiles to prevent strike through and dip gloves to improve the thickness of the glove. No need for multi-dipping. You can make your process more efficient if you like. We have tackifiers, a range of tackifiers. We produce tackifiers for dry rubber, and we can extend those tackifiers into water-based dispersions to really improve the tack. We have a lot of applications in terms of adhesive systems, tire inflation kits, for example, latex-based foams for tire repair kits, and a range of tackifiers in a very, very highly dispersed form in liquid media for many applications. One new product that we produced, if you like, for latex is a reinforcement agent. This is a water-based dispersion with a high solid content, 40%, but it's a real nano material. Very low loading, we can improve significantly the latex strength properties. So for example, if we look the tear and tensile strength with the 3 PHR loading of our reinforcement material, we can increase tear by 80%, really raise up 140% in terms of the tensile strength. So applied into natural rubber, especially pre-vulcanized natural rubber, significant improvements in latex tensile and tear with the very low loading of a reinforcement additive as possible, with very high stability, so we don't see any separation or stability issues. So really to improve that, we can get film thickness, we can reduce the film thickness for the same tensile and tear properties, so really improving the, if you like, the mechanical properties of latex compounds. Finally, the third pillar I'd like to talk about is our release additives. We have two different technologies in terms of release additives. Firstly, mold release. So these are coatings applied onto the surface of the mold to improve the release, to improve the wear efficiency of the mold, to reduce mold fouling. And secondly, talking about mandrel release. These are lubricants for the shaped hose application, if you like. So mold release, there are plenty of mold releases on the market. You'll find very simple silicone emulsions, soaps, waxes, all kinds of materials applied on the surface of the mold. But a lot of those release agents cause damage to the mold, they cause mold fouling, they really need to be applied at every cycle. On the other end, on the high end, you can find permanent, so people coat their molds with chromium plating or maybe with some special reactive vapor deposition technologies onto the surface. But we work with semi-permanent coatings. These are coatings that are applied to a mold, they cross-link, and they form a long-lasting coating that can be used for many moldings before it needs to be reapplied. So we'll talk a little bit about the advantage of this type of coating. Our aim is to really regularize, if you like, to make a high uniformity coating on the surface of the mold, to tune out, if you like, the micro irregularities and surface porosities that you'll see on the surface of a metal. So applying the coating really smooths that surface out, the coating cross-links, and really fills out the irregularities. So this would be an uncoated surface, this would be the coated surface with a much lower surface energy and surface friction. Sorry, you wanted a photograph? Please visit us on the booth, we're happy to show you. We know that because if we coat a mold, uncoated, coated, and we do an AFM microscope, electron microscope, to look at the friction, we can see a very high friction surface, uncoated, because the surface is very irregular. On the coated surface, the energy is much lower, a much more regular surface with a very high slip and release potential. It's very important to talk about the application of these coatings. The number one criteria is really to clean the mold. We want to bond our coatings to a very clean surface, so we need to remove the waxes or the lubricants that might be present. So we can talk to you in detail about appropriate mold cleaning. After mold cleaning, then we apply the material, it cross-links very quickly. We start molding, and actually we run in this loop, molding, releasing, using very often. Infrequently, maybe once every 50 moldings, once a shift for example, we simply reapply the coating, and much more infrequently, if you like, with a high duration, then we reapply the coating and remove the coating, clean the mold, and start from scratch. So mostly we're working in this very efficient loop, occasionally reapplying, and then much more infrequently really cleaning the mold. We can see the performance in terms of reducing mold fouling. So that's a injection molding, if you like, the spider mold, high degree of mold fouling. The same coating, a very clean mold, we don't have mold fouling. We improve the flow. You see the flow increased much more because of the reduction of friction due to the coating. So better flow, better release, and a reduction of mold fouling by using the coating is possible. We also develop new generation coatings that have a high durability, so they wear much more slowly. So early generation coating might last 50 cycles. New generation coating will extend maybe 50, 100 cycles, depends on your compound. So we can really track for more abrasive or wear likely, high durability coatings will resist that, if you like. So new generation coating, very durable. Earlier generation, more slippery, maybe reduce the flow restrictions, but will wear in a greater rate. So we can tune the coating according to the compound. So yeah, a wide range of materials available. Early products based on hydrocarbon solvents. Later generation are all water-based. Some newer technology products have a very fast cure rate. So typically these coatings require 5-10 minutes of cross-linking. Later generation products we call spray and go. You spray them, the water evaporates, and the coating is cross-linked. So your production guys can simply start molding immediately after applying the coating. There's no delay in using these products. And then some new generation products with high durability, long lasting, or very high slip. So it depends whether you want good mold filling, you have complex mold geometries, or you simply want a coating that lasts longer and has a greater durability against more abrasive coatings. So finally, talking a little bit about mandrel release. So these are release agents, lubricants used in the shaped hose business. The hoses are extruded. They're fitted, shaped around the mandrels to form the shape. The lubricant must act as a fitting lubricant to allow the hose to be positioned onto the mandrel. The mandrels are put in an autoclave, the hoses are cured, and then the same lubricant should allow the demolding of the hose. So we have quite a wide range of additives for different polymers in this case. So depending on a lot of the products based on EPDM for radiator hoses, water cooling hoses, some products for FKM, for NBR, all water-based, all high biodegradability in most cases, so you can simply wash these coatings away from the cured hoses with high stability, some liquid products, some gel products that can be injected directly into the hose. So people producing shaped hoses, these mandrel-built hoses, we have a wide range of different technologies that can allow the easy fitting and demolding of these hoses. So yeah, we developed some kind of product selector, so whether you start with cooling water, radiator hoses, EPDM or ACM for turbocharger hoses, or NBR for CPE for air conditioner, or ECO for brake, then we have different selectors, different products that are tuned then for polymer compatibility, that they really don't cause the polymer to swell, they don't have any influence on degradation or aging of the polymer, but provide this effective release, if you like. Also mentioned, apart from the liquid products, then we have paste and gel products that can be injected automatically into the hoses, so it removes the operator intervention in applying the lubricant, if you like. So yeah, we have productivity, we have better lubrication in fitting and removing the hoses, great thermal stability, we reduce in the same way that the mold coatings, the permalloy coatings, reduce mold fouling. These also reduce fouling of the metal mandrel, so the mandrels remain cleaner for longer. And very efficient removal, they're all biodegradable, and you can wash these coatings away from the hose after use, if you like, so very easy to clean. And with that, thank you very much for your time. We'd be happy to take questions, or please visit us on the booth 2 steps down the hall. Thank you very much.
Thank you, Mr. Collins. We have time a little bit, so if you have any question, please question him now.
Thank you.
Hi, Mr. Colin, what's your best product to handle mold fouling in molding process?
Mold fouling, actually, good question. So it depends on the polymer and the cure system.
For example, EPDM, both peroxide and sulfur cured.
Oh, that's always the magic word, peroxide, sure. So then we have a whole bunch of there are 2 approaches. One, you can put something on the mold itself to prevent the mold from accepting the fouling, so the permalloy coatings are effective.
Yeah.
But we also have additives that can be put in the compound that will also reduce the mold fouling.
Yeah.
If you didn't say peroxide to me, we have a wider range of products. When you say peroxide, then we have higher thermal stability, fully saturated. The answer would be one of our organosilicone products. We call it Struktol WS180. You would use it at very low loading, maybe even 0.5 pHr. Very thermally stable, so normally you're using peroxide because you have a higher temperature application in the end use. So this product would also be suitable for the service use. It's fully stable against the peroxide, very inert, would not reduce any compression set or consume any peroxide, and it will form a barrier to prevent, it will improve the mold flow, the release, and more importantly will reduce the mold fouling. Okay. So we have solutions both on the mold and in the compound.
Okay. Can it be which grade?
Yeah, the in-compound grade is called Struktol WS180.
Peroxide.
It's suitable for peroxide.
Sulfur?
Also suitable for sulfur is no problem. If we can solve the peroxide, it will work for the sulfur.
Okay.
If you say sulfur only, we can offer you a wider choice of additives, if you like. When you say peroxide, that narrows it down, if you like, to additives that are stable against your peroxide. But we have such additives.
Okay.
So this would be the answer, as well as some kind of coating on the surface of the mold, if you like. So 2-step solutions are available.
Okay. So the mold release agent also helps mold fouling.
Of course, yeah. A lot of companies talk to us and they say, actually, we don't have a release problem.
Okay.
We have a mold fouling problem. And when the molds get dirty, then the release gets difficult. So if we can keep the mold clean, we don't have a release issue. So although we talk about mold release additives, actually we should talk about mold protection additives. So when we apply these coatings, the molds stay cleaner longer. The time, I don't say you never have to clean your molds, but the time between cleaning gets much longer. So the rate of mold fouling can be extended to many more days. If you like, if you say you clean a mold once a week, maybe you can go to once every 2 weeks with a suitable coating. You can really reduce the rate of mold fouling with a coating on the mold. Sure.
Okay, thank you.
Yeah, thank you. Nice questions.
Anyone else? Okay, all right. So I think if you don't have any question, but if you would like to contact like our speaker, please go to the booth number F9, like it's this way.
20
Thank
meters
you.
away.
Yes,
We're very close
yes,
by.
very close, like from conference room 1. So thank you so much. Thank you for Mr.
Thank you.
like Colin to be our speaker today.
Thanks for
Thank
the opportunity.
Thank you.
Thank you, ladies and
then
gentlemen.
For next section is start at 12. Thank you. ขอบคุณค่ะ ขอบคุณค่ะ
Thank you. Thanks very much. Thank you.
and